Hi guys, welcome back. In this video, I'll be talking about integer types. So prior to Cairo version 0, there wasn't a native support for integers. But then in Cairo 1.0, they introduced support for integer types, which makes me wonder why was it important, what made them, or what were the consideration for them to introduce the integer types. And then we all know by now, if you watch my videos, you know that felt is a fundamental type or the primary numeric type in Cairo. But then there's some limitation when it comes to felt, that integers will be a good fit in such situations. Right, so some of this consideration is when it comes to security. Integers have like a strict size, which helps when it comes to things like underflow and overflow. You know, in felt, when an overflow and underflow occurs, it's silent. The system doesn't panic. But when you're working with integers, when something like that occurs, the system panics. That means we're able to know what really happened. And another thing again is the predictability. Because when it comes to the size, like I said before, and also the behavior, that means that you're sure that if something happens and there's an underflow or an overflow, the system is going to panic. Like, you know that something is going to happen and it won't just remain silent, which is a very, very huge consideration for us to have integer types in Cairo. So, and generally, I think the system is more resilient when you use appropriate types, right? Not in a scenario where you're working with like two numbers and you know that they won't exceed your wins 8. Let me say you're subtracting between two unsigned integer 8, and then you're sure that the value would not result to something higher than your wins 8. So it wouldn't make sense for you to use your win 256, right? So these are all the considerations, and I believe that this was more of the reasons why integer types was introduced in Cairo. So we already know by now that we have two integer types in Cairo, which is the unsigned and signed integer types. So I just made a list here so you can see how this works. So int 8 just means that it has 8 bits, the same way down to this point. So there is also usize, right, which is also like another way for you to write uint 32, because it also has 32 bits like U32, right? So I think this is just here because maybe or maybe not Cairo might implement MLIR, so that's beyond the scope of this video, but yeah, it is there. You can still use it in place of uint 32, right? So, and again, I also made like this, because this is like the variance range. Because when we talk about this uint, this is a range of numbers that can be able to be accepted into these types. So for you to calculate like uint 8, you're going to work with, okay, let's work with, because we are working with unsigned integers now, we are going to go with this formula, which is, let's say, this is going to be like U8 is going to be 2, 8 minus 1. So when you work this out, or when you solve this out, you're going to be getting 255, right? So similarly, if you're working with this with the signed variant, so we're going to have like I8, which is going to, where n is always the number of bits, right? Then we're going to work with minus 2 to 8 minus 1 is 7, right? To 2 to 7 power. So this is just going to basically be minus 128 okay, there is a minus 1 here. I missed that. There's a minus 1 here to 127. So you can see that any variable that we are assigning a value that is higher, any variable that is denoted as a type of signed integer 8, and then we are assigning, let's say we are assigning 200 to it, then it's going to panic. The system is going to panic because within this range, 200 is greater than 127, which is the positive side of this. Or even if you do minus 200, it's not going to be accommodated because minus 200 is lower than minus 128. So that is the whole idea of this range. So, and this is going to be important when you're trying to consider the type for your arithmetic or your expression, because you need to put into consideration the possible values, that the max possible value for you to be able to choose these values when you're working with integer types. So another thing again I want to mention is that you notice that we have felt 252 as a primarily numeric type in Cairo, but then you notice that all of this down to point 128 can comfortably sit in a field 252 field, right? But not your 256, because this is 4 bits higher than felt, right? It can comfortably sit in a felt field. So that brings me to how Cairo represents a 256 type. So this is, it represents as a struct. Let's say U256. Then it takes in a low of U128 and a high of U128, and then it closes it. Right, so this is basically how it represents U256, right? I just thought to mention that because of it can't comfortably sit in a felt field, then this is how Cairo represents it behind the hood. Also in Cairo, we have something that we call typed literals and also typed variables. So what this simply means is that I'm going to clean this off. So, you know, when you're declaring a variable, let's say let A be of type U8, and then we're going to give it a value of, let's say, 5. So this way of declaring a variable, you're going to say that it is a typed variable. But then there's also something called type literal. So here you say let 5 underscore U8. So this is just basically saying 5 as an unsigned 8-bit integer, right? 5 as an unsigned 8-bit integer, which is the same thing as this, because we are saying 5 is an unsigned integer of 8 bits, right? Or we're saying A is an unsigned integer of 8 bits, right? So this one is called typed variable, and this one is called typed literal. So in a case where we have, like, let's say we also have let B be U8 is equal to 3, right? So we can have C to be equal to A plus B. So for us, for this other typed literal, C can actually be equal to 5 U8 plus let's say let's 3 U8. So we're going to have 3 U8. So these guys are literally saying the same thing. And you don't even need to have a let, just go forward with it, and this works perfectly fine, right? This works perfectly fine. So this is a type literal, because the compiler will already know that 5 is an unsigned 8-bit integer and 3 is an unsigned 8-bit integer. So in a case where we have, you know that we've already established that for unsigned integer 8, it takes a max of 255. So if I come here and say 300 underscore, right, this is going to be a problem. The system is going to panic. Of U8 is going to be a problem, because we are saying that this is an unsigned integer of 8 bits, and then we are giving it 300, which is more than the max that U8 can take. So these are all the things to put in consideration. These are all the things to look out for when working with integers. And also, you can actually use underscores for in between a large number. Let's say 1 million now can also be written as 1 underscore 000 underscore 000. This is very understandable by the compiler. Compiler really understands this. So you can also write this for readability purposes. You can use this. If you have even a higher number, you can still keep going, right? And it will still understand it, right? So, isn't that cool? It's actually cool because all these things are actually put in consideration to make your code more readable and all of that. So another thing I want to talk about is type conversion. You know that at the end of the day, everything goes back to field, but then you can still do the conversion in your code, right? So you can use traits or functions like into and also try into for these conversions. So let's see how we can convert an integer type to another integer type, right? We also see how we can convert an integer to, okay, let's make it one way now, an integer to a felt, and then a felt to an integer, right? So let's say we have a function, a sum function, for instance. We have a function of, let's say, sum U8 to U16, right? And then it takes two parameters, right? Let's say A is of a U8, comma, and then B is of a U8, and then it's going to return U16 for us, right? So, and then we have something like this, and then something like this here. I don't know why I keep getting this wrong. Yeah, let's work on this. This one too. Yeah. So, what is going to happen here now? We have because we are taking in two units, 8. So if we do the sum outright and then return a value, is going to be of type unit 8, which is going to throw an error, right? So we need to first convert it to a unit 16. The reason why I'm doing this is if I'm doing a sum, and then what if A becomes 255 and then B becomes 255? You're going to see that the value I'm going to get is going to be more than the value that your 8 can take, right? Okay, let's take this guy to be 255, A plus B, and this guy to be 255. Then we are going to have 255 plus 255, which is obviously bigger than the max that a U8 can take, right? So that is why I'm making my value to be my return value to be a U16, and for me to be able to return a U16, I need to convert whatever I get into a U16 type, right? So I can actually do what we are supposed to do now. We are supposed to convert these guys now into 16 so that our return value will automatically be a U16. So again, say let x of type U16 equal to A into, right? The same thing, let's y of type U16 equal to B into, right? So at the end of the day, I'll return let sum equal to x plus y, then I'm just going to return sum. So this way we've been able to convert this guy, which is U8 into U16, right? Which is something very possible when it comes to Cairo. And again, the same thing happens when you're doing an integer to a felt. You just need to replace this to with felt 252, felt 252, And then you're going to say that you're returning a felt here. You get the point. So when it comes to felt integer, it's a lot more. So here now, it means that we are going to be accepting felt here, or for the purpose of this space, I'm just going to put F here. But you're normally supposed to write it out. So, and then this guy, the return type would be, let's say U16, right? Then here, so we're going to give it like U16, and then we are here now. It's not just going to be only into, so you're going to use try into dots. Unwrap, the same thing here. Try underscore into dots. Unwrap. So at the end of the day, your sum is an integer because the conversion happened here, and then you return your sum, right? So okay, this is meant to have here brackets. So that is basically it, and you can see all that you can do with integers, and it's really cool because for the sake of the security, the predictability, and basically the general resilience that it brings is a very, very important type in Cairo. So at the end of the day, when using integers, you make sure that you find out the max value that you're expecting from your operation, and then that will give you insights on what type to use. So it wouldn't make sense that you're working with 2U8 and then your return type is doing 256. It wouldn't make sense because that would be a whole lot of waste of space, right? So that's why it's important when you're making your choice for the type to use for your operation, then you have to consider the max size, and that is why this formula is here for you to use, for you to calculate for the signed variant and then the unsigned variant. So with all this being said, you can now work with integer types in Cairo, and you won't be confused why something is this way and why it's the other way. And thank you guys for watching, and until next time, keep building peace. Bye.